Today, we're dealing with an IC fault, and we'll be replacing the chip. Before we begin, let's get all the necessary tools and materials ready. Here's what we've prepared: a hot air gun for quick heating and removing the damaged IC, tweezers for precise handling of small components, a brush to clean residue around the chip area before soldering, a new IC chip, which is the key component in this repair, soldering paste to improve solder joint quality and increase flowability, PCB cleaner to remove soldering residue and keep the board clean, a temperature-controlled soldering iron for stable and accurate soldering, and finally, a multimeter to locate the fault and verify the repair result. These are the essential tools we commonly use for IC replacement on LED modules. First, we identify the faulty area on the front side of the LED module. The faulty IC is usually located directly behind the damaged area on the front side. Normally, ICs are arranged in groups of 3. The first controls red, the second green, and the third blue. In this case, we're replacing the middle one, which controls the green LEDs. To ensure accurate positioning, we disconnect the adjacent resistor to make room. Then check again from the front side to confirm we've located the correct IC. Next, we use a hot air gun to heat the area, setting the temperature between 300 degrees Celsius and 350 degrees Celsius. Gently heat the IC until the solder softens. After heating, we perform another quick test to make sure no other ICs were affected during the process. Before removal, apply some flux to improve soldering quality. Then, reinstall the resistor back to its original position. Carefully remove the faulty IC. Using a soldering iron set to about 300 degrees Celsius. Gently clean off any solder residue on the IC pads. All operations should be done carefully to avoid damaging the pads. Now that the area is clean and ready, we can move on to installing the new IC. Before placing the chip, carefully verify its orientation to ensure it matches the circuit design. Precisely align the IC with the pads, confirming each pin corresponds accurately to its solder pad. Gently position the chip onto the pads, avoiding any bending of pins or damage to the component. Then, apply solder evenly across the pins. Once soldering is complete, use tweezers to gently press down on the IC to prevent poor contact or lifted pins. Use the soldering iron to carefully remove any excess solder from the pins and pads. This helps prevent solder bridges and ensures clean, precise connections. Work slowly and methodically to avoid damaging the pads or lifting any pins. During soldering, you can apply a small amount of flux as needed to improve fluidity and ensure better soldering quality. After the soldering is done, visually inspect the solder joints to ensure they are full and free of solder bridges. With the new IC soldered in place, we move on to testing and cleaning. First, we power on the module to perform a basic test. The display appears normal, indicating that the repair was initially successful. Next, we clean the soldering area using PCB cleaner. With the help of a brush, we remove any remaining flux residue to ensure the surface is clean, reliable, and ready for continued use. Once cleaning is complete, we power on the module again for a final test. The display remains stable, confirming that the new IC is functioning properly. Finally, we remove the defective label from the module. At this point, the repair process is complete. If you encounter any issues during similar repairs, or need professional repair tools and spare parts, feel free to reach out. Follow us for more LED repair tips. See you in the next video.